Now let's look at the future. Over here we see the projected temperature changes starting from year 2000 to 250 and 2100. And these are temperatures in centigrade. They are ranging from 0 to 4 degrees and 8. This 4 degrees centigrade is roughly 8 degrees Fahrenheit. So projection shows us that for southeastern United States, or over this area, is a greenish square, we have temperature forecasted to go up and could be 4 degrees Celsius, which is 8 Fahrenheit, could be a little less for different scenarios. So if we behave differently in terms of emitting greenhouse gases, we can have the range of temperatures as high as this red bar or as low as this blue bar, depending on different scenarios. But even in the most favorable scenario, it's still going to be about 3 degrees Celsius, which is 6 degrees Fahrenheit. As Judy mentioned, it's not a very big number. Day-to-day variability of the weather is sometimes bigger than that. So what? I can feel the temperature, but barely notice the 6 degrees. And I will talk later why the 6 degrees are important. It's not only temperature change, and all the other stuff: precipitation, increase of the sea ocean level, ocean level, and increase in the frequency of extreme events. Altogether, this stuff is going to be effects of climate change in Georgia. So this is in words the projection of the IPCC, 3.6 to 18 degrees Fahrenheit. This is spread between those scenarios.
Do the last 8 years fit the same model since that ends at 2000?
I think so. Yeah, the trend is for Georgia is going up as the rest of the world right now. It was dropping in the middle of the century, but now it's going up. These are in a little more details projection temperatures for year 2100 from IPCC. So you see this isotherm of a 3 degrees centigrade around Georgia. So this is what's predicted. Much higher temperature change in the north and less in the south, where Georgia has about 3 degrees. It's on a color scale over here. For the precipitation, picture looks a little more promising or better, so we don't have much change. It's probably a 0 to 5% plus, so a little increase in precipitation. But I will talk about it later. It doesn't mean it's going to be very uniform precipitation over the year as constant level. It might be variable. So when we consider these results of the model projection for Georgia, we have to be very careful. Why? Because the models are not perfect, and those predictions are good for general, good for average all over the world. They're probably better than for specific locations. Why is that? Because of the grid cell, or the minimum size, which is considered size of the surface, which is considered in the model, is probably around 2 to 3 degrees latitude and longitude, maybe 5 degrees in some models. And that pretty much covers all of Georgia. One single square would cover all of Georgia. So those models will not give you any good information what's going to happen within the state or on the smaller scales. Because of the resolution is too coarse, and the high resolution that is used in the weather models cannot be run in climate models. Climate models simulate the climate for hundreds of years, and they need to be run over a very long period of time. And if you have smaller grid size, you will run out of time. You will not get any results soon. It will take too long to calculate, too long to run the model. So the simplification is done, and the grid size is bigger, which has a negative sides, of course. With this coarse resolution, the water is not resolved very well. And this is one of the reasons why the models are not giving good forecast. Also, tropical cyclones, which are important for Georgia. It's one of the significant sources of rain in the fall, in the end of summer period, because cyclones bring moisture from Gulf of Mexico, from Atlantic, and they are not resolved in climate models, so they will not show up there, and therefore the precipitation estimate could be a little off. Aerosols and clouds is another subject, another reason for global climate models be not very precise predictor right now, because aerosols affect clouds and clouds reflect sunlight. So little subtle changes in the aerosols will result in change in the clouds, and therefore result in the amount of solar light that passes through, hits the surface. Dynamic processes like El Nino, La Nina, and other large-scale variations of the weather that affects climate are not very good resolved in the models right now. So also this affects the precision of the climate forecast. And many other processes which our scientists are working right now on, and we are going to have a better forecast as all this improvement are put into models.